Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with lesson number 100 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you by lesson number 100 already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. I'm going to show you my solution to the homework assignment that I gave you in lesson number 99. But I must start by asking how many of you were able to do it. If you were able to do it, leave a comment down below. I am legend. Double chest bump. If you weren't able to do it, leave a comment down below. I folded up like a cheap Walmart lawn chair. Now, hopefully most of you guys were able to do it, but what we did in lesson number 99, I showed you how we could control the position of the servo by very precisely creating a pulse train using our state machine, and then to send values of desired position to the state machine from Python. So the timing is controlled by the state machine and the position that we want is controlled by the Python program. Now what your homework assignment was now, instead of just running one servo, independently run two servos. To do that, what are we going to have to do? We're going to have two state machines. So what I want to show you today in the next few lessons, how we can work with more than one state machine. And there's different ways to do it, and I'm going to kind of show you the different ways to do it today, and then we'll move forward a little bit more on this project in next week's lesson. But I thought it would be more fun to really understand how to use more than one state machine in the context of a real project like controlling servos, rather than just going through some sort of just made up something with the program. So I know also that some of you, we know Charlotte loves to check in on the fishermen. Let's see if we have any fishermen. Yes, we've got our friendly fishermen out there, seeing if they can haul in a catch today. We'll be checking back on the fishermen as the video progresses, okay? But let me come back over here. And what I want to do in today's lesson is I want to start with that code that we had last week, because I don't want to go in and develop everything from scratch. So what I will need you to do is go to the most excellent www.toptechboy.com. I need you to use this happy little search tool here and search on something like sweeping the servo with the Pi Pico PIO state machine. It should bring you to this lesson. You can come down here and use using these two happy little page icons. You can click. You copied the code to the clipboard, and then we're going to come over here and we are going to paste the code. We're going to paste the code from last week, and then I'm going to see if I can get my system set up here. And what did this do? For one servo, it would smoothly sweep from 0 to 180 and then back to 0. Let's make sure that the world is in proper working order, and we're going to see if the code still works that we had from last week. And so I'm going to run it, and look at that. We're going from 0 to 180. We get to 180, we sweep, we wait 5 seconds there just to show that we can maintain that proper pulse train even if Python is pausing. And what we can see is it is sitting there and adjusting the pulse width, which is controlling the position of the servo. Even though we did this last week, it still makes me happy. Even a week later, it's still making me happy that that thing is working. So we're going to come back over here to our code, and we are going to see if we can now make this work for 2 servos. So the first strategy that I'm going to show you is maybe the most straightforward. What I am going to do is I am going to put in a second function. So I'm going to get all of this stuff we did. We notify Python that machine code is coming, then I give it a function. Well, I want to do that again for the second state machine, but this time, did I put that in the right place? Okay, yeah. So this is the first state machine that we did last week. I think I got too much here. Let me get rid of that. I copied too much. Now this is going to give it notification that I have a new state machine function coming in. Well, if this is servo set, I better call this one something else, right? So I'll call this servo set 2, all right? And then I come down here. Now, I have instantiated the first state machine. I have made it active. I have sent it the pulse width that the period that I want, and then I pull that period into the state machine 0, and then I move that period to ISR. Well, we need to do the same thing here. We need to do the same thing here for what? We need to do the same thing here for state machine 1. Now I am instantiating a new state machine 1. Now what is going to be different? State machine 1 is going to be using pin 21. Okay, so this one used pin 20, and this one is going to use pin 21. All right, now the frequency is still 2 million, but now I've already used state machine 0. I want this to be what? State machine 1. Now I'm going to make state machine 1 active. I'm going to give state machine the pulse width I want it to use. I'm going to pull that state machine. I'm going to pull that 20,000 into the OSR of state machine 1, which is state machine 1 here. And then what I am going to do is I am going to move in state machine 1 from state machine 1's OSR into state machine 1's ISR. So now state machine 1, which is, this is a little confusing. State machine 0 knows what the pulse width is, and state machine 1 knows what the period is. All right, so both state machines know what their number is, right? Both state machines know what their base pin is, okay? That's all good. That's all good. Let me just look at this here. I'm just looking and making sure everything's good. Okay, everything is good. Okay, yeah, I'm just looking and making sure I did all that right. And so now I have 2 state machines with their functions defined. They know who they are, and they both, what do they both have? They both have the period that they should be using, and both of them should be using 20,000 microseconds for their period. Is that good? I think that's good. Now what we need to do is I've got those 2 set up. Servo set for state machine 0 and servo set 2 for state machine 2. So what else do I need to do? This needs to now be what? It needs to be that second function, servo set 2. So state machine 1 is going to use servo set 2 function, which is here. Does that make sense? Okay, let's make sure. Yep, that looks good. I want to make sure that I'm doing all the modifications that I should. I think I am. Okay, so I've got 2 state machines instantiated, 2 state machines loaded with a function, and 2 state machines that know who they are and know what the period is. All right. Now what I'm going to do here is, in this function, what am I doing right now? I am sweeping state machine 0. Well, what I want to do now is I want to sweep state machine 1. Okay, need to get rid of that like that. And so now, just like I put into state machine 0 the pulse width, what I'm going to do here is I am going to put the pulse width in state machine 1 and state machine 1. Okay, but this time, instead of putting the pulse width, right, I want them to go like this. As I have it set right now, they would be going in tandem because they're both getting the same pulse width. But we need to show that we are independently controlling them. And so this, if I kind of went through the math, I can get the inverse of this if I just did 3,000 minus the pulse width, would then make this one be going in the opposite direction. Now here, I want to take all of this state machine 1 stuff, and I want to also do that. I want to also do that here. What is all of this stuff down here? I've got a lot of extra stuff here. I'll worry about that in a minute. But here, I'm going to do this for the second state machine. Why do I have all of this extra code? Let me go back and look at my program. For some reason, it's like I double pasted or something. I'm not sure why. Okay, I've got servo set. I've got servo set 2. I set up SM0. And then I set up SM1. Then I've got my while true. And I've got my first for loop, my second for loop. But then somehow I ended up with another copy of the program here. So I'll get rid of all that. The funny thing is that was not in what I just pasted. So maybe in this blank thing, maybe it wasn't completely blank. All right, so let's look over this. Notify Python that I have a state machine function coming in. This is the state machine function. Notify Python that I have a second state machine function coming in. This is the second state machine function. Now in the instantiation, state machine 0 knows that it is state machine number 0, and it knows that it should use what? The first function, right? The first function. And then state machine 1, as it is instantiated, it knows that it is state machine 1, and it knows that it should use what? Servo set 2. It knows that it should use servo set 2. Then I go ahead and activate it. I give it the 20,000 microsecond period. I pull it to the TX, and then I move it. I pull it, and then I move it from OSR to ISR. So that's all right. Then here, what do? I sweep from 0 to 180, and then I am operating at the same time with 2 different state machines. Okay, does that make sense? So it's kind of like just doing what we did for one and doing it for a second one. So man, this is kind of crazy stuff. I'm a little afraid of running this, so I will really need everyone to hold their breath. Boom, look at that. Okay, so do you see? These are operating in opposite directions. These are operating in opposite directions. They both hit that end, and they're now in the 5-second delay, and now they're going back. Now also look at this. I've connected both channels up to the oscilloscope, and we can see that as one state machine is getting a bigger pulse, the other state machine is getting a smaller pulse. And if we looked at, I believe the yellow is this one, it gets to the maximum, and then it waits. The yellow is the maximum, it waits. The blue is at its minimum, and now they're sweeping oppositely back to the other position. Okay, that really is, could it be that easy? Could it really be that easy? It could be that easy. Okay, but let me show you what the problem is. So what happens if I just, in this first servo set, what if I wanted like 16 no-ops? So I'm just going to say no-op. And this isn't going to affect the timing because it's not in no-op like that. I'm going to do 16 no-op. No, I'm going to do 8. Okay. No-op like that, and no-op like that. So I put in what? Man, I can't type today. And you're not even seeing this. Okay, I think I can just back up and show you. And I'm sorry, it's very hard to think about state machines, and it's very hard to manage what you're seeing. Okay, so we're going to come back over here. Now, what I'm going to do is, that worked very, very simply, right? So now what I'm going to do is say, what if I wanted to add some code to the first servo set? So I'm going to do a no-op like that, and then a no-op like that, and then no-op. I got to start copying and pasting. I can't type today. Like that. And then no-op like that. So I've added 4. And then what I'm going to do is I'm going to come and I'm going to get those 4. I'm going to paste them. And now I have 8. But you see, that's not going to affect the timing because it's up here outside the wrap target. So I'm just adding lines of code. Now, what if I also wanted those lines of code copy? And then what if I wanted those lines of code in this one as well? Okay, so I'm just adding code to the 2 state machine, the 2 functions for the 2 state machines. Now, if we run it now, okay, it still works. That looks good. Well, what instead of 8, what if I wanted 12? So I'm going to put 4 more. I put 8 more. So I'll take 4 out. 1, 2, 3, 4. Okay. So now I think I've got 12 if I'm counting right. So I'm going to take 4 here, and I'm going to put them down in, I guess I did that to the second one. Okay, so I'm going to come here. All right, so now I've got 12 no-ops in servo set, and I've got 12 no-ops in servo set 2. So now I'm going to run it, and I get an error, and it's an E-N-O-M-E-M. M-E-M sounds a lot like memory. Well, if I have 32 lines of code that I can work with, this is 12 lines of code, and then what do I have? 13, 14, 15, 16, 17, and then 18, like 18 lines of code. Well, I thought I could use 32 lines of code. So what is my problem? And to show you the problem, there's something very important that you have to understand about using more than one state machine. There's something that you have to understand about using more than one state machine. So let's come over here and let's look at this. Let's see if I can draw this. With a little luck, I can draw this. Okay. So what I have is I have a PIO. Okay, and in this PIO, I have state machine 0, state machine 1, state machine 2, and state machine 3. And I'm going to go ahead and label these just so it's very, very clear. So this is state machine 0, state machine 1, state machine 2, and state machine 3. Okay, now I have a second PIO block. I've got a second PIO block here. And what do I have in it? I have state machine 4, state machine 5, state machine 6, and state machine 7. And I didn't draw that too perfectly, did I? But I can come in and I can label those. State machine 4, state machine 5, state machine 6, and state machine 7. Now what I also need to see is this is PIO block 0 and this is PIO block 1. And I don't know if it's 1 and 2 or 0 and 1, but there's 2 PIO blocks. Each PIO block has 4 state machines. This is the dirty little secret, and that is that these 4 state machines share the 32 line limit. Okay, and these 4 state machines share the 32 line limit. Okay, what does that mean? This one, this one, this one, and this one can only combined have a total of 32 lines of code. And over here, if this function has 18 lines of code roughly, and then this one has 18 lines of code, that is a total of 36. And that will not fit into 32 because state machine 0 and state machine 1 share that limited amount of space. They share that limited amount of space. So you can see that what I'm doing here, I put in those no-ops just to show you that each state machine cannot independently have 32 lines of code. Okay, so now what could we do? Let's come back over here. That's not, what is that? That is not useful at all, is it? Let's come to this one. Okay, now what could I do? What could I do? This one has 32 lines, and this one has 32 lines. And what did I use? I used state machine 0, and I used state machine 1, and I overflowed it. What is a way around it? Instead of the second function being on state machine 1, what if we put it down here on state machine 4? Now that one would have its own 32 lines of code total, and this one could have 32 lines of code total. So what can I do in the code? What I could do is over here, the second state machine, instead of putting it on state machine 1, I could put it on state machine 4. Now, I can still call it state machine 1. That doesn't change anything, but it's going to go to 4. All right. Now, since I have one state machine on PIO block 1 and the other state machine on PIO block 2, now I should be able to take advantage of all that memory. So now I run it and boom, look at that. So let's come over here. Let's look at this view. And now, even with those extra lines of code, I'm not overflowing my memory because I am using both PIO blocks. But at first glance, you would think, oh, I have 8 state machines times 32, and that's how many total lines of code I can have. No, I can have a total of 64 lines of code. I can have a total of 64 lines of code shared among 8 state machines. 4 state machines sharing 32 lines of code, the other 4 state machines sharing the other 32 lines of code. Okay, so this was this was kind of like a little way of doing things. Okay, this was a little way of doing it. But now, if I wanted 4 servos, it wouldn't work. If I wanted 4 servos, it wouldn't work. But what I want you to see here is, this function is the same as this function. Those two functions are the same. So I am going to take out the second function. Okay? I'm going to take out the second function. You didn't see that, did you? I'm sorry. Like I say, it's hard to manage all of this. Okay, so what I want you to see is this state machine function is exactly the same as this state machine function. So what I'm going to do is I'm going to take this one out. Okay, I'm going to take this one out. And now, what am I going to do? I'm going to go back on state machine definition here. I'm going to change this back to state machine 1. So I've got state machine 0, I've got state machine 1, and I'm going to have them both use the same function because this one can independently be running that function while this one independently runs that function. So the 2 state machines are going to be running the same function, and so therefore I don't consume all of my code, all of my available memory. So let's come in and let's run this. Okay, line 29 it doesn't like. What did I do wrong? Did you guys see what I did wrong? Well, I am puzzled, so let me undo what I did. Servo set, servo set. So what I can do is I can come in here and I can have both using the same function, which is servo set. And it doesn't like it. Okay, I am a little bit confused why it didn't like that. I think I see what I did wrong here. I left that command in there saying that there's machine code coming, and there was no machine code coming, so I should have taken that line out. Let's hope that fixes it. Boom. Okay. Well, guys, you don't know how bad that scared me because I thought I am sure that you can have two state machines on the same PIO block sharing the same function. And you can see it's pausing for the 5 seconds. And then they're now working independently in opposite directions. And everything is working fine. Everything is working fine. Now let's come over here and you tell me what you think would happen if I come back over here now. And what if I said this is state machine 0, this is state machine 1? What if I made that state machine 4? And if I ran this on the other PIO block, what do you think would happen? Okay, let's run it and see what happens. Okay, so what you can see is state machine 4 can still use the function that was set up here. It can still use the function that was set up here. Because what did I do? I called that servo set 2. So all of these can share that same function. But now what I have is I have 64 lines of code that I can work with instead of 32. Does that make sense? I hope it does. So we've shown that both state machines can share the same memory and can share the same code. Now what you got to remember is each one of these state machines has its own FIFO TX and its own FIFO RX. So how many FIFO TXs do I have? I have 8. How many FIFO RXs do I have? 8. How many OSRs do I have? 8. How many ISRs? 8. How many X registers? 8. How many Y registers? 8. So those things are independent of each other, but across both state machines, you can save the same memory. Now, what we could do is we could come in now and we could go back and we could put in a second function and have that second function associated with this other state machine. Okay, you could do that, or you could just say you could share that same block of code, that same block of memory across the two PIO. Okay, man, I hope that wasn't too confusing, and I hope that that wasn't too tedious. We've got the fisherman still out there. Now, this is pretty cool. Okay, this is pretty cool. Now, what is the one part of this that I don't like very much? The one part of this that I don't like very much is this code for a person that all they care about is they want to make a little dial that moves the servos, and they don't want to be thinking about pulse widths. All they want to be thinking about is angles. But you see, now my main Python code has in it state machine commands that the casual user is not going to be able to understand. And in fact, if I just gave this code to someone, they would not understand what this is. Okay, what is this pulse width business? So what I want you to do is, I want you for next week, I want you to create a class. So I want you to put all the state machine stuff up at the top of the program, and I want you to define your state machines by calling that class. So I could have, what could I have? I want to see if I can say this carefully. I could have a class called servo state, and then I could create servo 1, servo 2, servo 3, and all of that ugliness of how the state machine works is handled inside that class. And then what your program does is it just passes the angle to the servo object that you create. Now, why am I doing this? I know a lot of people struggle I know a lot of people struggle with classes, so I want to continue to give assignments where you have to generate classes because they're really important. And so that is the more advanced lesson and the more advanced homework for next week. You create a class that takes care of all of the stuff associated with the state machine at the top of the code. And then when you get down here, all you have to do is just pass the servo object that you create, the angle that you want, and all the calculations are done up in the class, okay? I hope that makes sense. Let's check on my front yard here. We haven't looked at my front yard in a while. Okay, I showed you last week we got the rabbit food back there. I'm planting my corn. We've got all of our potatoes here. And I see an incredible, there's somebody up there working. So right there, there's somebody working. Got a little bit worried because I wasn't seeing a lot of activity out there. But yes, we do grow most of our own food here. We got the fisherman, a little bit of a picture of what's going on here. But guys, I hope that this is not becoming too tedious for you. It's just in this class, I really want to dive deep so you're not just sitting there copying and pasting other people's programs. You're learning how to operate a lot closer down to the transistors. You're operating more at the bare silicon level. And as you're able to do that, a lot of that work you want to hide in classes. And then the simple stuff is down in the Python main loop. I hope that makes sense. I hope you guys are having as much fun taking this class as I am making it. As always, I want to give a shout out to, and a big thank you to you guys that are standing with me on Patreon. I cannot do this type of deep level instruction without having you Patreons, because there's not hundreds of thousands of people watching these more in-depth videos. And for me to do this, I need to have the support from you guys that are helping me on Patreon. So a big thank you to you. You can also help me by giving me a thumbs up on the video and leaving a comment down below. If you haven't already subscribed to the channel, when you do, make sure you ring that bell so you will get notifications when future lessons drop. And as always, share this video with other people, because the world needs more people working on state machines and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.